Hello, everyone. Please welcome on your screens now for the opening keynote on day 2 of SODACODE Demo Days. Richelle Ahlvers, Storage Technology Enablement Architect at Intel, and Yuji Yazawa, Principal Engineer and Group Manager, Toyota, for the opening keynote. Over to you, Richelle.
Thank you. I am Richelle Ahlvers. As noted, as Storage Technology Enablement Architect. Some of you may wonder what that is. We basically get to go play with all of the latest, greatest new technologies. So today I'm going to talk to you a little bit about a couple of things, one of which is I focus mainly in the storage arena. So I'm going to talk to you a little bit about some of the new and emerging technologies that are coming out, and also how both we as companies get involved and help drive and accelerate those, as well as some opportunities for you in the development community as well, particularly in the open source space, to also engage and help accelerate the technologies that you find interesting. So, talking a little bit just about some of the technology trends in storage. Cloud has been around for a long time. We started with really this notion of a public cloud, and then we also had a notion of a private cloud. And then we had the development of what we call hybrid cloud, and which is really, being able to seamlessly move data back and forth between public and private clouds. Well, we're now expanding that definition and looking at what we're calling both multi-cloud, basically generically multi-cloud, but there's also the notion of intercloud being proposed as well. But this is really some expansions in the way you use clouds to allow the ability to use multiple clouds. And also to have those work together. So you avoid a little bit of lock-in there. Some of the other technologies, I can get that to advance, there we go. One of the other interesting things that's coming up as well is in what we call computational storage. So computational storage is a model that allows us to basically, as it says here, move the compute closer to storage. What we're really looking at doing is offloading work that is very focused on data manipulation down from the compute, the general purpose compute, down to dedicated compute that is right next to the data and helping to accelerate that process significantly. Next, we have data accelerators, looking at how we can optimize data translation throughout the stack. It's a very well-known stack. Let's look at how we can optimize it. There's a lot of work going on in this area. It's very interesting. Next, we have expanding interconnects. So one of this is focusing on CXL. So if anyone hasn't heard of this, is the Compute Express link. What this does is it delivers what we call cache coherent disaggregation. So instead of having your memory held captive and dedicated to an individual processor, you have the option to take your memory, your accelerators, and even your memory-based storage, like persistent memory, and make those into pools that can be much more readily shared across your CPUs and across multiple hosts. So you can think of that as moving to a fabric-based environment, which leads us into one of the next areas. As we're seeing this proliferation of storage fabric technologies, we're also seeing an increased demand for how to manage those both consistently with servers and with server storage and network management for multiple applications of those fabrics. There's also the notion of blockchain. This one is coming up as what are the applications for blockchain to storage. So these are just some of the kind of interesting technologies that we're working on, particularly in the SNIA organization that I'm on the board of directors for. So I want to talk a little bit about why some of these consortiums and standard development environments exists and why we engage with them. Fundamentally, it is to accelerate the development of these technologies in a standardized way. So as you can see here, there's a lot of different places that SNIA works. One of the things we also do is we leverage and work with other organizations quite extensively, so that we don't have to bring everything into a singular organization. If another organization is working on something, we look at how we can partner with and leverage to, again, accelerate the development of that. And in many cases, the companies engaged in these consortiums are in multiple consortiums working across these different areas. So just as some examples of that, we have a couple of organizations that have been around for quite a long time, the Fiber Channel Industry Association, FCIA, and STAY, the SCSI Trade Association. We partner with them on a lot of the basics for the SAS or SCSI protocols, SAS is leveraging. And then when you get to Fiber Channel, you're looking at how do we partner with these organizations to look at that storage networking interconnect technologies. Moving on a little bit to manageability. Manageability is a key element, and obviously near and dear to my heart. The storage management space within SNIA focuses on managing just the storage. What we do is we partner with our other organizations, our peer organizations like DMTF, who has server management, in order to expand out and cover the whole space without duplication. We also partner with the NVM Express organization for both manageability as well as computational storage. So this is a really good example of what I was talking about earlier, where we have both SNIA and NVM Express working on computational storage. Some of the other places we work and you partner with, the Green Grid, CXL, which I mentioned on the previous slide. CXL will be looking at everything from manageability to integration of SDXIs, those data accelerators, and computational storage into a CXL environment. All right, and we also work with open communities such as the Open Compute Project, Open Fabrics Alliances. These are not, and the SODA Foundation, these are not organizations that typically develop their own standards. They leverage the work that happened in the rest of these standard organizations and focus on their value add. So how can you get engaged? This is really a fairly straightforward process. What we just need to look and do is identify, what is your area of interest? Maybe it's one of the things I just listed. Maybe it's another one. Is this something that will help you day to day and is part of your job, or just something that helps pique your interest and you are, want to spend some time on and learn about the specifics of the technology and help accelerate. So that's kind of one of the keys here is we'd like folks to get engaged, but we also want to have it be for purpose, which is to helping to accelerate and expand that technology's ecosystem. So we find the ecosystem for a particular technology and look at identifying some of the opportunities that exist there. These go everywhere from some of the kinds of work that I do, like contributing to the definition or defining the technology and the specifications for those. In most cases, you need to join the org and start contributing. This is largely done by member companies, but most of these organizations have a significant number of member companies. You can also just contribute directly to the ecosystem. This could be working on development tools, test tools, helping to create or build a reference implementation or an emulator, or maybe even working on clients of a particular technology to help flesh out that ecosystem where we have implementations coming and you want to balance that out with clients. Many organizations now develop these kinds of supporting materials as open source. So just a quick example here. Looking at, again, standards-based management. What a shock I would use this example. What we want to do is identify the technology of interest here. So, storage management, okay, we're there. What's going on in this space? Well, what we have are Swordfish and its partner Redfish, which gives you comprehensive REST-based server storage and fabric management. Well, what do I do next? I go look at that ecosystem. One of the easiest things to do is check places like GitHub. So on GitHub, you can easily search and find SNIA and Swordfish and see that we have a bunch of open source projects that allow open contributions after simply acknowledging the contributor's licensing agreement. So there you go. Now all you need to do is look at contributing. All right, thank you very much. I will at this point turn it over to Yuji.
All right, thank you. Then let me show my presentation. All right. Hello. I'm Yuji Yazawa. I'm responsible for the vice chair of governing board and chair of end user advisory committee of Solar Foundation, as well as principal engineer and group manager of Toyota Motor Corporation for responsible for the deploying next generation IT infrastructure, which is dedicated for connected vehicle and autonomous vehicle. So let me quick introduction for myself. I'm Yuji Yazawa, and most of my experience was spent on the storage area. So first, I was joined in Yahoo Japan and responsible for managing server and storage products. And I managed a couple of 10,000 of physical servers and a couple of petabytes of storage products. And after that, I moved to vendor-side company for such as Fusion.io, SanDisk, and Scality. And after that, I got back to end-user company, which means current company, Toyota Motor Corporation. And in the 2018, Toyota was joined to OpenSDS, and OpenSDS was changed the name to Soda Foundation. And after around 4 years, I mean, after we joined to Soda Foundation, at first, there are only few companies and only few persons worked for the developing and discussing soda related. However, we are growing up, and we succeeded to invite more people and more companies. And I'm really excited we succeeded to arrange hackathon such as SODACODE. I'm really glad to speaking to this keynote session. Anyway, if you're interested in working in Toyota, please contact to me directly. So today, let me explain. Let me talk a little bit about automotive use cases. As you can imagine, Toyota connected vehicle will grow, generate a huge amount of data, as you can see. So if we put kind of intelligent function into the each vehicle or load or something like that, we need to expect a couple of exabytes or couple of zettabytes of data. So this is actually current preliminary assumption of the capacity of the data, which calculated in the AECC, which means Automotive Edge Computing Consortium. And then the connected vehicle will sending many kind of data, which is sensor data or camera images or something like that. And the data will processing on the we need to expect edge environment or on-premise data center and couple of public cloud environment, which is AWS or Azure or something like that, as well as we need to realize DR using replication function or something like that. So I mean. We need to use many kind of storage products and many numbers of storage products. So we are really expecting SODA continue to growing up and improve the function and the sustainability. So anyway, I'm really glad to SODA could succeeded to arrange the SODACODE as a hackathon, and we Toyota have many challenges around the storage environment, especially. So if you are interested in working on Toyota, please let me know. Thank you. That's it.
Thank you so much, Yazawa-san, and thank you so much. Oh, sorry, I'm so sorry. Thank you so much, Yazawa-san, and thank you, Richelle, for the open keynote today here at Day2. Your insights have always been welcome, and thank you for your continued support of SODA. With that, we will now move to the next session. Thank you.